Okay guys, this is the last video I'm going to make tonight. This finishes up that extra credit worksheet I gave you last week, okay? Before I proceed, however, I want to remind you guys, this video you ought to really study. Watch it multiple times, take good notes on. I'm going to give you some specifics, in other words, that may be strange to you, but it's going to be very important as you get into the upper level math classes, okay? So check this out. All they want us to do here, guys, is you could see the graph is already done. We're going to analyze the graph. We're going to want to know when it is increasing, when it is decreasing. All right? So let's start there first. So when is this graph increasing? Well, basically, guys, it's like reading a book. Start at the left part of the graph. And see where I put the dot right there next to the arrow there, right? So start there, and you just follow the graph from left to right, just like you're reading a book. So if I start down here, notice I'm going up. See how the graph is going up as I go from left to right. This is what we refer to as increasing. Notice right at this point here, we would call this a relative maximum value, okay? Because it reaches like a peak or highest point, right? That's the fancy name for it. It's called a relative maximum point. And after it reaches that peak, what does it do? Well, after there, does it not just go down? Again, see how I'm just tracing it out from left to right? And it keeps going down, right? It keeps going down this way. At the beginning, it was going up. It reaches a peak called a relative maximum. Then, as shown in green, it's going down. Now, notice it reaches another peak there, although this one is a bottom peak. It's called a relative minimum, okay? That's what it's referred to as. And after it reaches its relative minimum, what does it do again? It goes back up again, doesn't it? See how it's going back up. So when it's going up in purple, that's increasing. When it's going down in the middle part of the graph, that's what we refer to as decreasing. So I'll switch to black so it's easier to see. The bottom line is, how can we describe or show this? We would just simply say it's increasing, and we would give an interval. Looks similar to an ordered pair, but basically we're going to put a parentheses. We know the left end is considered negative infinity, guys. Everyone's used to the sideways railroad track, right? Or sorry, racetrack symbol. This is infinity. That means it goes on forever. And it's actually increasing from negative infinity all the way up to that point right up there. Everyone see my big black dot right there? And that point is right here where x equals 0, right? And then notice if we follow the purple again, it's increasing, and we have to approximate that, looks like, at about 2.8, let's say. So it's increasing also from about 2.8, and when the graph goes all the way with an arrow to infinity, we refer to that as positive infinity. And finally, the middle part in green is where it's decreasing. And that interval is from 0 to our estimate of 2.8. And these are not ordered pairs, guys. This is the way we show intervals. And these intervals describe what we call the domain of the function. Remember, domain's a fancy name for the x or input values. Okay, and so this is something you have to get used to. So pause the video and take notes on this. And if you don't mind, go ahead and give the next problem, I believe it's number 67, a shot. All right, let's see how you did. This should be the last problem, guys. So no, we just basically have a regular good old quadratic parabola, right? So when is it increasing or decreasing? Well, does everyone agree? You always start with the left end. And this time, notice how the graph would be going down as I trace it out, right? So again, that would be referred to as decreasing. And notice again, it reaches the bottom here. Since it's a parabola, we would also call that our vertex. Remember that? And that vertex, we would again call it our relative, in this case, minimum, since it's a bottom peak, right? So let me make sure I spell decently there. So relative minimum value. Okay, those are M's there, guys. So that vertex is a relative minimum value. And then, of course, after that minimum value, it's curving back up, right? The curve just keeps going back up, correct? All right. And, of course, in purple, that would be referred to as when the graph is increasing. Bottom line, when the graph is going down, it's decreasing. When the graph is going up, it's increasing. It's that simple. Now comes the tricky part. Get used to the interval notation. When is it decreasing? Well, the left end with the arrow is again referred to as negative infinity. And it bottoms out at the vertex. Notice right there at x equals -1. So we would say it's decreasing from negative infinity up to -1. When is it increasing? Well, it's increasing from that -1 vertex all the way up there. The arrow on the right end refers to as positive infinity. And so, guys, as I said at the beginning of this video, take good notes, get used to the terminology, get used to the weird notation that looks like ordered pairs, okay? And get to know increasing and decreasing. See you in class.